Exam 3 review. We just did some problems expanding some expressions, and so now we're actually going to condense some expressions. Let me go ahead and do this. Awesome. Okay, so, and then y'all, these right here still apply with condensing. You would just go from the expanded version into the condensed version. Equal signs mean that they're both equal to each other, like quite literally, right? They're equivalent. So you can go both ways. Okay, so we are on problem 17. Problem 17 says 8 natural log of x minus 12, and then we have a negative 9 natural log of x. Okay, so for what? Oh, I thought I was on problem 16. I got really confused there all of a sudden. Did I do? Yeah, I did that on the last video. Okay, problem 17. So what I'm going to notice first, since this is an expanded form and I'm trying to go to condensed form, is that I have coefficients, and coefficients become exponents. So let's go ahead and make those exponents. This 8 becomes the exponent here. This 9 becomes the exponent there. I get natural log of x minus 12 to the 8th power, and a negative natural log x to the 9th power. And then what I notice is, since this is a difference problem, this actually comes from the quotient rule. And so I would write this as this is my m, this is my n, and you do m over n. So I have natural log of x minus 12 to the 8th power divided by the I was going to say the natural log, divided by x to the 9th power. And so that's your answer here. Okay, let's look at problem 18. Problem 18 says 3 log base 6 of x plus 5 log base 6 of x minus 6. I hope y'all also realize too, whenever I apply these rules, all of the bases are the same, right? Even in the formulas, they all have base b, which means that they have to be the same base, okay? That's going to be the only way you can apply the rules, is if the bases are the same. Okay, so the first thing that I notice here is I, again, have some coefficients. So what I want to do is go ahead and turn them into exponents, and then what we get is log base 6 of x cubed plus log base 6 of x minus 6 to the 5th power. And then because this is a sum of these two logs, this is saying that my m and my n are multiplying each other. So we have log base 6 of x cubed, and then you could open parentheses just to write your x minus 6 to the 5th, the same way it's written right here, okay? And that is your answer to that problem. Okay, so let's look at problem 19. Problem 19 is log base a of x plus 2 log base a of z minus log base a of y. What I'm going to notice here is that I do have two different operations. I know that if I'm taking the sum of two logs with the same base, their m and n, right, are going to actually be multiplied together. And then if I have the operation like a difference, right, the operation of like a minus sign, then that's going to be whenever I put them in a fraction form, because they would be dividing each other. And so what I want to do first is actually the product rule. And so what you would get there, applying the product rule right here, is log base a of x. Oh, look at that. That 2 is going to become an exponent. So right there, z squared. And then we have subtract from that log base a of y. And now this different sign means that what you do is you take log base a of x, z squared is your numerator, y is your denominator, and then that is your answer. Sorry, I didn't say that first. I was actually reading something as I was talking. Okay, so that is going to be how you use the properties of logarithms to condense a logarithmic expression. And the directions also say to write the expression as a single logarithm whose coefficient is 1. So all of these coefficients are 1, and it's just one logarithm, one natural log, not multiple. And so I will actually go ahead and do 20 and 21. The directions are different, but they're short and easy, so we'll just get these knocked out. For problem 20, it tells me to use common logarithms or natural logarithms and a calculator to evaluate to 4 decimal places. What I have is log base 4 of 13. And then for 21, what I have is log base 21 of 388. I actually can't use common logarithms or natural logarithms. Common logarithms have base 10. Natural logarithms have base e. And problem 20 has base 4. Problem 21 has base 21. So because of that, what I actually need to do is use the change of base formula, which, if you remember, it was going to be you take the log of your big divided by the log of your little. And my big number is 13, my little is 4. Here, my big number is 388, my little is 21. So literally, we're going to take just log of 13, and we're going to divide it by log of 4. Then, of course, we're going to get an approximate answer here. It tells me to evaluate to 4 decimal places. And so if we do this, we get log 13. And then make sure you close that right with the parenthesis. And then divide that by log of 4. What we get is 1.8502 when we round. So we have 1.8502. That is your answer for this one. For 21, we're going to take log of our big and divide it by log of our little. So that's log 388 and then log 21. So we do log of 388. We're going to divide it by log of 21. And what I get is 1.9579. 1.9579. And so that is your answer for that one. I'm going to stop here and I will be back. We'll probably do 22 through 25. If y'all have questions, let me know. Bye.